Bon matin, good morning, and good afternoon for our remote attendees. So today that's PR5. We have been asked to give you an update about the standards that we are using, especially in the product room. So we will talk about some ISO standards dealing with properties, templates, dictionary, models to implement those dictionary, and so on. So that will be the first part. And the second one, I will give the floor to Stefan, who will talk to you about level of information needs and maybe the connections we may have between those standards and level of information needs standards. So this is me. Well, I've changed my glasses, so that's why I'm telling that's me. Still, yeah, I'm a member of the product room of the steering committee of the product room since I don't know 2 years, something like this. I'm working at buildingSMART level as a kind of dictionary expert, and I'm a member of CMTC 442 and ISO TC 59/2013. That's the reason why I've been asked to talk to you about those standards. I'm also a member, of course, of the French standardization body, which is mirror committee of those BIM committees. You know, standardization, you have international level, European level, then national level. And in real life, to be able to give some food to my family, I'm working for a Norwegian company, which is called Cobuilder, and I'm in charge of some insurance too for this. So, quickly, a bit of history, maybe, well, there is an animation, but you can go to the end of the slide. This is the last one. A bit of history. I have a lot of pressure because Ogin Root is in the room and is the chair of CMTC 442, so please interrupt me any mistake I make. It may happen.
I'm watching.
Well, everything started in 2014 with the creation of CMTC 442 dedicated to BIM. And so we created several working groups, and one was called WG4, where the plan was to deal about dictionaries, objects, templates, the description, everything we will talk about right now. And it's ended with two different standards. One is called EN ISO 23386, which has been published in March 2020. The second one is called EN ISO 23387, published in July same year. Then there is something missing on this slide. Sorry about this, what about? Because I'm talking about EN ISO 1206-3, revised, published this year, but there is a long history behind it. That's not in this timeline, but I will explain you later on a bit of the history according to what we used to call IFD. Just a second. And the last standard is, and it is misspelled, but this one is currently under revision, so it should be written EN ISO 23387. Sorry about the one at the beginning. This is under revision. I will explain you later on why and what will happen according to it. So many numbers, many standards, but we will go through all of this. What is important to know is that most of the standards that we'll talk about have been created in CMTC 442. Some of them have been revised in ISO TC 59/2013. But I mean, we are all talking together. That's not someone in CEN doing something. Then surprise, it's happening at ISO level, or surprise, this is a buildingSMART thing. We have the liaison. buildingSMART is liaison member of CEN and TC 59/2013. I mean, Oyvind is in the road for a buildingSMART event, but he's leading those two standardization things. So what I mean is, this is collaborative work. A lot of people are involved in this, engaged in this, and are discussing together. Those guys are not saying the content of this standard, it will answer my use case, and I don't care about buildingSMART or ISO or whatever. All those guys are discussing, and to be completely frank, usually that's the same class. But still, that's not silos. We are all discussing together. All those standards have been discussed at all those levels. And then, yeah, immediately when we started in TC 442, so 2014, we were all babies and talking about we have kind of an issue to solve. Just a quick example. I'm an engineer, and in my BIM project, I will have to deal with Eurocodes. I will have to deal with specific acoustic regulation, acoustic standard like EN 12, blah, blah, blah. And I have plenty of different sources of information. For some, I will receive a PDF file. For some, I will buy a specific access to my standardization body to be able to read the standard. And the question is, then what? What can I do with all those things? No common way to define the things. And when I say things, I'm talking about objects, templates, properties. No common way to define this. No common way to change this. No common data model. Almost nothing. So that's pretty cool. We are talking about BIM, interoperability, but when we want to talk about data, exchange, information coming from standards, and compressive strengths, that's a property coming from a Eurocode. I need to be able to know what I'm talking about. No way to do this. So that was what, the issue we decided we need to solve, and then that's the three standards we will talk about this morning. First is called ISO 23386, and it's dealing with process, property definition, and mostly quality and trust. The idea is really to push on, I should be able to trust the content I'm getting from a dictionary. I mean, that's perfect. We can have 10 dictionaries in the world, and I'm doing my dictionary, because I'm French, and I'm really proud I can do my dictionary. Then Christophe is doing his dictionary. Who's right?
Me.
Probably not. But I mean, we have to be able to have experts on Eurocodes. If I go back to my example, saying, Christophe is right. Frédéric, maybe he's right too. Let's discuss. So we have just one property, and we will describe it the same way. That's the goal of this first topic. Then, okay, we agreed. We have a way to define things and to trust the content because we have processes and blah, blah, blah. We'll come back to that. Cool. Then I did a model to store this information. And I did something that allows me to exchange this information in a standardized way. ISO 12063, IFD for the old guys in the room. And then something more. We need another standard that will allow us to describe what is a data template. I will come back to this. And this standard will explain me how to structure information around an object, and it will use the first two standards. And that's the reason why we will talk about those in this specific order. First, 23386, then the model, the API, to exchange information, and then 23387 to help you structure. This is high-level data model. This is lower level explaining to describe the template. This is the way to go. And then, if you can go to the next slide, please. Let's start with my favorite one, ISO 23386. That's the best standard because I was leading the project. If you can go to the next one. Yeah, so a bit of history on this project. This is an old story. Once upon a time, I invited a manufacturer that was in Oslo, really more than 10 years ago. And I told him, we have something which is really cool, that's called BSDD, a long time ago. Never forget I did this. And I told him, come with me in Oslo, you will see it, you will love it, you will use it. So he went with me in Oslo, we left the meeting, and he said, no way. I was like, wow. And that was all about trust. His point was, oh, you got something, but I don't know who has put this something in the SD. I don't know how it has been created, who has validated it. So that was his point. And we didn't think about it before. So we had the technology, but we were missing this kind of piece to govern the content of this. So we decided that, yeah, we need to have a standard for this. We need trusted definitions. A huge statement we had that definition of a property, that's not its name, plus the textual description. This is no sense to describe a property. That's really more than this. I will come back to that. As I told you, we need a standardized way of defining those concepts. We also assume that we don't need a lot of things to do that. properties and the way to group those properties should be enough. Should be enough. That was the statement for this working group. And the last statement is, we had a dream that was to be able to create a dictionary to rules of all, Lord of the Dictionaries. And it didn't happen. But if we are able to have several dictionaries following the same process, following the same way of defining content, and being able to interconnect all those dictionaries, then we have kind of this dictionary to rules of all. But that's a lot of different dictionaries interconnected, following same process, same way of describing. So at the end, you should end with almost the same idea, but not with just one thing. Well, still, if we are able to do this, let's go. But still, if we are not, we have a solution to handle this problem. So, this standard is containing three main parts. The first one is how to define, well, I'm talking about properties and groups of properties. And the idea there is to say, to be able to do this, we will add a kind of set of what we call attributes, which is a bit misleading. We are talking about terminology in buildingSMART, but when I'm talking about attributes, Russell will understand property because IFC has entities and attributes. In my case, attributes are metadata to describe a property, and that's kind of issue we had, and we should have somewhere kind of lexicon or whatever explaining IFC, entity, attributes, 23386, groups of property, save, and draw the lines, because this can be misleading. Whatever. We are describing a property or a group of property with some metadata, a set of information that will allow you to create this property in a way everyone is understanding the same. And that's the first part, but the second one is the crucial part, and that's the main part of 23386, in fact. That's workflows to author and maintain the content. And that's back to the story I told you. It allows you to have a way to know exactly who has created something, why did that, when, and who has validated it. I mean, if I go back to my example, Christophe is creating compressive threads because he loves it. And in his airport, he needs a lot to have these compressive threads. But David is an expert from the Eurocode community. And he will check if what you did is really following the standard. If it's right, green stamp pushed in the dictionary. If it's wrong, send you a message saying, hey, have a look at this, what do you think? And then you can discuss. So that's the second part. And of course, the last one is, as I told you, if we are not able to have one dictionary to rule them all, we need to be able to interconnect the dictionaries following the same standards. So, right, you can click many times. There is an animation, but it doesn't matter. It should have been nice. So, this is an example of a property. I have this one just for the property, not for groups of properties, because that's almost the same. Just imagine it could be a group of properties. So, these are the metadata you need to have to be able to describe what you're talking about. Easy, a list of names in any language. Then you can have a list of definitions in any language you need. And as I told you, this is not enough to describe what is a property or what is a group of property. It cannot be enough. But then, if you add the data type, that's better. You know that this property, when I provide a value for it, it should be a string. It should be an integer value. That's a bit better. Then you might have a link to a reference document. Back to my example, Christophe has created compressive threads attached to a Eurocode. Then David, which is an expert of Eurocodes, he knows he has to check it because you've got this link. And the user that will use this compressive threads, he will know I'm using this property coming from this standard, and I have to do it by rule. So that's a really important one. Of course, we have something called dimension. That's all about physics and physical quantity, describing exactly the seven base quantities and these kind of things. Well, it's a bit technical, but again, that's really to describe completely the property. Unique identifier, should have written with, that's the name we used to use. To be clear, this one is the same as DOS, but for a computer. Name in French, in English, in Dutch, name for a computer. This one is unique, and this one is the one we trust when we exchange information about this property or this group of property. Something else we have, it's called status. In a dictionary managed following this standard, nothing can be deleted or removed. No way. The only thing you are allowed to do is to deactivate something. Saying, this is not anymore active in my dictionary, but if Jean-Paul has created a nuclear power plant, because in France we love them, maybe in 15 years we will have to maintain it. Oh, now it's well, to be serious, he's been using a compressive strength at this time, and we had a new standard coming 10 years later with a new property for the compressive strength. When in 20 years we will discover that this nuclear power plant has leaks, we will have to check the properties that has been used to create it. If they have been deleted or removed, we're in huge trouble. If they are just deactivated and we have the information, this has been replaced by this one, then again, that's a win. We always know what we are talking about. So you are not allowed to remove content, just to replace it and to deactivate it. And that's really, really important, even if, when you are talking to technical guys, this means that technically you will have huge databases because you have to keep track of everything that has happened in the dictionary. But keeping track is also about trust. That's the reason why we have this. So the next one is, I'm following just to be sure, that's about the process. So in 23386, you will find some really good BPMN, business process model and notations, if I'm right, following the standard, another one. And those BPMN will explain you exactly how you should manage your dictionary. So now we know that to define a property or a group, I need to have a name, blah, 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 blah. Okay, then as a user, as Michel, I will create a property for CRB, one which is really needed for EBKB. Right. And when I will click submit, the only thing that will happen is sending the request to a set of experts. And those experts will review what Michel has done. Even if he knows exactly what he's talking about, we have to check, we have to validate. So that's the expert committee that will do this. And I'm always saying the same thing, but we all know that as soon as you have more than one expert in the room, maybe two, they will disagree. That's how it is, that's right. Two experts disagree. So in the standard, we said that we should have a steering committee on top of this, not all about governance of the content. That's, we had this discussion with some of you guys in the room earlier. That's all about governance. Those guys at the end will decide what happened, and it will be written clearly somewhere. Expert has disagreed on this. Steering committee has taken this decision because of this reason. So no black box at all. Everyone needs to know exactly what has happened in the dictionary. Next slide, please. And then the last part is the easiest part of 23386, because the standard is saying we need to be able to interconnect dictionaries, and to do that, please have a look at another one, which is IFD. So 23386 is saying this is how to describe things. This is how to manage the description, quality control process, and you need to be able to interconnect the content following IFD, which will be the one who structures the content and provides the ability to make those connections. And I will come that in 3, 2, 1. Now, let's talk now about IFD, which is, I told you, mostly about the data model to handle the dictionary, and about providing a standardized API. Can you go to the next one, please? And here we have the history of it. There is a huge legacy around IoT. I think the only last guys from there are David and Radloud. Oh, sorry, and the boss, Roger. So those guys, I was too young, I was a baby still, so those guys, they've been working on something that they call International Framework for Dictionary, and the goal was to be able to model the content of the dictionary, to store it, and to exchange it. Please stop me when I'm wrong. You're the one. So, and I think the first version of the AFD standard was published something in 2007? Six. I told you, those guys I know, they wrote it. So in 2006, that's the date that was missing in my timeline at the beginning. First version of IFT. Of course, buildingSMART International was really involved in this, and that was the starting point of, first that was the property server, and then the buildingSMART data dictionary. First version of it, that was based on this, and IFT was the engine of the first PSD, who stayed alive for, I don't know, it stopped running last year or 2 years ago. So that's not something who lasted 2 months. I mean, that was something really present and based on this 1206-3. So if we can go to the next one, then the question was, why shall we revise this standard? I mean, clever guys working on this, it works, it is implemented in a tool, so why should we revise it? That's because of the story I told you about my friend in Saint-Gobain and blah, 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 and trust about the content. That was to be able to address what has been added by ISO 23386. History, tracking, versioning, these kind of things that were not inside it, and we had discussions, should it be inside it, shouldn't it be? Some people think it shouldn't. I don't have a strong opinion, but at the end, that's it. So you are able to track everything. An important point that was not planned for the first IFT was to be able to manage classifications. BSD was able, because Katenda was in charge, made some tricks in it to make it happen, and it was working really well, no problem, but that was not in the standard. So that's why we wanted to revise it. Multiple dictionaries, important, we already talked about this. Again, that was not really in IFT, but in BSD that was the case with something we used to call contexts, which was again a tweak created by the team. It was working well, but that was not in the standard. The idea was also to provide a really standardized read access API, meaning that everyone using the standard is using the same API to do it. And I will come back later on to 23387. But it was also a reason of revising the standard. So yeah, we can go to the next one. So I know on this part it will be a bit technical, so I'm sorry for the one who are not really interested in this, but we have a data model. We've been working on it with the same clever guys who were involved in the first version, and that was really important because you had legacy on it, and you knew exactly what was the goals of the first version and where to go with this. So thank you for this. That was a real help for all the group. So we have a data model which is starting by something called root for computer scientists. That's really cool and really usual, let's say. But what I want to show you is what we have as main entities in this model. We have something called dictionary. I will not explain what we mean by this. I think that's really clear. We have something called user and user withdrawals. That's to be able to handle the storage of the processes. Who did what, when, who is an expert, and so on in the dictionary. And we have something called object, which is kind of high-level thing, which can be a concept, a relationship, or a change request. Adding because again of these processes. And the more important is what kind of concept we are dealing with in this. We are dealing with documents, subject, properties, and filters. But nothing else. And if you can move on for that, just to say, hey, I've been working on this. Can you believe it? But we can skip it. That's not interest. This is just a view of the UML model where you will see what I told you: root, object, concept, subject. So really quickly on this one. That's the way we used to work in computer sciences. If you have something which is subject, we have a set of metadata in common with other things. These things in common are one level up and one level up and one level up. That means that everything that is handled using IFD has, for example, a unique identifier. Everything in the dictionary has a grid. So if you access the dictionary following this, every piece of this dictionary is uniquely identified with because of this. And well, if you remember, I told you 23386, we have names, definitions, description, physical quantities, blah, 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 blah. And we need to revise IFD to be compliant with this. And if you have a look, this is the status, active or reactive, version number, when it was created. Here we have the famous link to documents I showed you, list of definitions, of descriptions. I think the names are here. So that's all. We created a model to be able to handle the metadata we need to manage a dictionary. And something a bit specific that has been added, and I have a slide after this to kind of compare what we used to have and what we have now in IFD. There is something we have decided to create in IFD. That's the way to use homemade relationships. Usually, when you want to describe something, I would say I want to describe a window. It has a glazing part and a frame. To do this, I will create window and I will say as parts or is decomposed by or whatever you want as a name. That's a relationship. But you can also say, I want to describe a bridge, and this bridge, it has pillars, it has blah, 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 blah. That's not really a decomposition. That's mostly parts of it. That's another relationship. You may want to describe the dictionary following the classification system idea, saying I have window, then I have wooden window, then I have steel windows. In this case, that's a specialization property. So, first version of IFD had a set of relationships fixed that you may use. In this one, what we said is, why not letting people creating the relationship they need in the dictionary and describe them as you describe a property or a group of property. This relationship means this with a definition. Maybe it's defined in a document somewhere, you can find information about it and so on. So when you use IFD, you have to create your own relationships. That's important because when I will talk about 2337, we will come back to this. And something else with those relationships is that we are able to scope the relationships. So let me explain. Here we have something called a radiator. So in IFD, that's a subject. You can say that's a construction object. You can say that's a template. I don't care. That's a subject for the model. And then you have something else which is called thermostat. And I'm able to create a relationship which is called regulates. So in my dictionary, I'm saying there is a kind of relationship which is regulates, and I'm able to say regulates is connecting radiator and thermostat. So I will know that the thermostat regulates the radiator. Cool. But IFD allows you to go a bit further by saying this relationship is valid for a heating system. So I can have another entity saying this is a heating system, and I will know that in the scope of a heating system, a thermostat regulates a radiator. So that's an add-in in IFD regarding the first version. No fixed set of relationship. You can do whatever you want, which is cool and which is dangerous. And that's the reason we will come back to that later. But I mean, if LOIN is creating a specialization relationship for PDT Norway, and Michel is creating another specialization relationship for CRB, you can do it. That's valid. But if LOIN wants to talk to Michel about the description of the template, they need exactly to know that it is the same relationship. If not, they need to understand what it means and so on. So it can be dangerous. We let you do whatever you want, but when you do whatever you want, things can happen. Usually that's not things, but it can happen. So that's one of the reasons why I will explain more in 23.7. And something else we created in this standard that was not present in the previous version, that's what we call filters. That's a quite cool thing, and you already saw it on Tuesday with the DigiBase presentation. This allows you to say that IFC wall plus is external equal true plus is log being equal true is the same as a specific classification code. So that's a kind of, you can call it mapping, we call it filtering, but you are able to make connections between something and something with specific values and specific properties. And again, that's exactly the use case you've seen on Tuesday. BSD is implementing that. So you are able to say IFC wall plus log bearing true plus is external true equal, in their case, that's NNSFB 22.1 or something like this. And that's kind of cool, because you have many use cases on this. I mean, I receive a BIM model, press the button, connect to a dictionary following 1206-3. I will be able to classify all the content of my BIM model by just taking the IFC entities plus their properties. If they are well described in the dictionary, I will be able to do that. The other way around, I'm receiving a BIM model with all unique class code inside it. I will be able to check if those codes are valid according to the properties attached to the IFC. So yeah, for me that's a huge functionality we have added in IFD in 1206.3. That's this filtering thing, if we can, yeah. And this is a I've made this kind of presentation many times, but when discussing with David, I thought that was interesting to have a really slight comparison of what we had, what we have. IFD V1, we had XTD actors, XTD bags, subjects, and nests. Now we just have subjects. They all handle the same thing, meaning that a subject can be a subject, but can be also a bag or a nest, meaning that can be a group of things. So those were created to group things, now we still do it. And the second major change is we had this list of relationships. I hope I didn't forget some, but that's not the point. So we were able to say that this actor acts upon this, that we can associate this subject to this subject, and so on. So that was a fixed set of relationships, which was working really well. Here we decided just to have what I shown you, this relationship to subject plus relationship type, and then in your dictionary, you have to create your own relationships. So that's, well, of course, we have all the difference, we have added attributes and things like this. But for me, the main differences are those one. No more actors, that's your subject, no more bag and nest, that's again a subject, and no more list of predefined relationship types. You can create the one you want. And in short, yeah, why did we revise it? Now we have just subjects, properties, unique dimensions, enumeration, and using filters that we didn't have before. We can create any time story of relationship in our dictionary. We can track history of what has happened in the dictionary, and we have a standardized API. So if you buy ISO 1206-3, and please do it, you will have what you need in your software to be able to connect to a dictionary following 1206-3. And I mean, if it's me, if it's PL Airport, if it's CRB, whatever, same API. So easy to implement. That's not easy to implement, I'm wrong, but that's a common way to implement it. And we also provide, this is not normative, but we provide an XML schema allowing to export the content of the dictionary in an XML file and to exchange it. I'm not sure if we have many use cases on this, but still you are able to do it. at least maybe to check the content of it, I don't know, but you are able to follow an XML scheme. Thank you. Last one. Please feel free to interrupt me anytime you need, if there is something unclear or if you have questions. So that's not too long monologue for you. The last one is 23.387, which is about data template, and I decided to put it at the end because it's using both of the previous templates. That's the reason why we are talking about this one. Yeah, thank you. So, what is the data template following 23.387? Oh, that's quite easy. We have something called the construction object. Let's say that's a window. This construction object can be defined, or is defined in a specific ISO document, so my window can be connected to it. And then I'm creating as many data templates I need to describe this window. So this is my EM blah 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 data template. No, ISO. It is connected to an ISO document. Then I will have many different sets of properties. Each written set of properties to avoid people make the confusion with IFTP sets. Even if at the end, except the name, the meaning is pretty close. All those groups of properties are able to be connected to reference document again, and then you have the list of properties that can be attached to a group or directly to the template. So in short, construction object window can have a template, a specific template to describe it. It has a list of sets of properties, dimensions, I don't know, EPD content, etc., really specific things, with the property inside it. This is what 23.387 says. And then, if you go to the next slide, no. This has been published, as I told you, in 2020. And it was using IFT, ISO 1206.3, and IFT has just been revised. So we have to revise 23.387 to use the new concepts coming from IFT. And to be honest, we already knew it when we published 23.387, but the idea was to have the basis of it, and when IFT revised, to update it to use the new structure. So in fact, if in 23.387 we were using XD relationship to, I don't know, then you cannot do it anymore. That's the reason why we update 23.387. So no huge change, just to manage to follow the new standard. And the goal is to have something, or I hope that's right, for summer 2024. And well, same as the window earlier, but now we just have documents, templates, set of properties, document, and we have relationship between them, meaning that template is connected to the construction object. You can have specialization between different templates, between different construction objects. You can have dependencies between properties. You have documents attached to set of properties. So same story, but here, what we are saying is IFD, really cool. I can do whatever I want. 23.387 is saying, okay, let's use IFD, but let's agree on the main relationships we need to create the template. So we can avoid that Alvin and Michel are creating their own connection between template or a construction object. That Jean-Paul and me, we are creating our own data template to set of properties connection, just to make it easier to exchange. So what we did in IFD by removing the list of relationship in 23.387, we do it the other way around, but really in a small context of a template. Yes.
First question. The construction object, could the construction object also carry properties? Because this seems to be necessary in our opinion as well.
Right now, only the template has properties. So the construction object is a kind of high-level thing which can be only described with templates.
Because from the industry, they call us that there's a need to have also properties for the construction object, because it's not the summary of templates, it's more than the summary of templates, in their opinion.
So two answers on this one. The first one is, please join the standardization group, because this is ongoing work, well, one of you. And all input is always very welcome. And then I would say that you can still do it. Maybe that's a bad solution, but here you can have a breakdown structure of data templates. You can have a high-level one with high-level properties, and then you can break it down.
Okay.
So it could be, I don't know if it's the right one. We need to think about it. But then, yeah, please join us, work with us, and all input is always very, very welcome.
Thank you.
Specifically, when you have specific use case that we are not able to address, we have to know it. I mean, that's now. That's under revision, so if we have to make updates, we will. Then you have to talk with all the nodes, then you agree that you are able to address. No, I'm joking, that's really easy to follow this code. So if you can go to the last one, which is a bit technical, but this is the goal. I show you the window connected to this and this and this, and this is the way that it will be handled following IFD. So if you can click 3 times, thank you. This is XD subject, sorry for the misspelling. So we will have a subject for the construction object, a subject for the data template, a subject for the group of properties, and we will create those famous relationship subjects that I showed you before. But in the standards, they will be fixed. So this is just, that's not fixed yet, that's proposal, but a construction object can have a relationship as data template. Data template can have a relationship as groups of properties. So that's under discussion. The group will decide what are the best relationship to have, but that's the idea. Using IFD, which is really high level, and making the scope smaller just to answer the specific needs we have to describe a data template. And yeah, thank you. This is the end of my presentation. I will give the floor to Stefan, if he's still alive after my long talk. And I just want to introduce him with this last slide, which is Stefan will talk about level of information needs. And in level of information needs, they need something to describe what they call alpha numerical part of a requirement. And could be a data template, in my opinion. Could be. So that's ongoing discussion, and that was the best way for me to introduce Stefan. We will have this kind of discussions. Of course, we are discussing between standardization groups, not to reinvent the wheel in each one. So we are discussing at which level 2337 could be, or may be used, or can be used by the LOIN group. And Stefan, the floor is yours. Thank you.
Okay, thank you for the introduction. I'll share the screen then. So I hope I'm showing the right screen. I don't, if it's needed, please give me a sign. So this part of the presentation is to introduce you to level of information needs as part of the SEN standardization work and also the ISO standardization work. So my name is Stefan Boeykens. I'm a BIM consultant for the studio in Belgium, but also part of the standardization work at the Belgian level in the National Mirror Committee. And as part of that, I'm a co-author of the EN 17412 part 1 that has been published. So the first part of the presentation is present you to what has been published so far, and as part of level of information needs in November 2020, and then show you what the ongoing work is to further develop parts 2 and 3, and also to see the alignment with the other standards. The concept itself, level of information need, effectively is something that has been defined in ISO 19650 in chapter 11, and also as a term that has been introduced. But it's a broad term. It's at a high level. It's a framework to define extent and granularity of information. Contrary to what many people seem to adopt today, but there is no acronym. But of course, we've seen the use of the acronym in many places already. So that's maybe the difference between a standard and what people are doing. However, at this point, it has been developed as a European standard and has been published. So not yet an ISO standard, but that is something that is being prepared. So it's a framework standard. It defines concepts, as part 1 defines concepts and principles. And the idea is that we should focus in projects to deliver the minimal amount of information needed to answer a requirement. That is typically defined in the context of being purpose-driven, being efficient. Don't overload projects with waste, effectively, and with the minimal amount of needed. Everything else should actually be considered as waste, and also at the risk of having technical issues, having overload of information, or not having the right information. There is some relation to the concept of level of development and level of detail, which have been widely used across the world. I think from the experience we have in Belgium as well, and in many other countries, the guides like the BIM form specification are commonly applied. And there is a notice the concept of a level of development is introduced, and also the levels have been defined. However, within level of information need, there is no, as it has been made a decision to not define a fixed set of levels, and not try to, on the one hand, reinvent the wheel, but also not try to fix everything into one fixed system. We have to understand that the standard, the concepts and principles give a methodology, you could say a language, to specify information requirements. And there is a clean separation between what are the prerequisites and what is the required information. The guidance and examples have not been included as in part one, which did help to get the standard published, but of course, which would be really valuable for the industry to start adopting it. So that is what we are preparing right now. And at the same time, also an exchange format to make the level of information need specification exchangeable and across software systems. The framework itself, at the most simple level, could say before you can specify your level of information need, you need to define the prerequisites. And the prerequisites are effectively comprised of several aspects. The purpose, why do you need information? When is information required? By whom should information be delivered, and to whom? And effectively how to describe the information using an object within a breakdown structure, something like a classification or an existing schema. The idea is that the prerequisites have to be considered and have to be defined, but they are not a part of the level of information need itself. It's only a context in which your information needs will be specified. The effective specification is based on the three main concepts that we will further develop in this presentation. So the prerequisite, the purpose, is considering the purpose. Why is information required? Sometimes it's made very explicit. It's needed for quantity takeoff. It's needed for a cost estimation. Information is required for a building permit. In other cases, it might not even be made explicit, probably in the context of requiring sensitive or information with a high level of security. But it's important to understand that the way that level of information need is applied, it's not specifying the purpose. Purpose is chosen, and based on that, so you have to consider the purpose. The same way delivery milestones, they are not defined by level of information need, but you have to align those to the milestones within a project phases, specific gateways in the process, or the different stages of delivery. At the same time, you also have to consider who will receive information, who will send information. But the information itself is agnostic of the actual company or partner or person to receive it. And finally, the breakdown structure is a way we decided to make it quite generic. You have to identify some object in a breakdown structure to be able to identify your information needs and link it to your information model. In most cases, we would say that should be a classification system, but it could also be a specific project breakdown structure or cost coding or a work package, the subdivision, which is valid for a project. And again, the level of information need in itself does not specify that breakdown structure. Once those prerequisites have been defined, then we look at the further subdivision of the level of information need in three main types of information: geometrical information, alphanumerical information, and documentation. And typically alphanumerical information and geometrical information are widely known and already applied, for instance, in the BIM Forum LOD specifications. But it is possible that we can, well, we can make a combination. Sometimes not all that information is required. Sometimes you only need geometrical information. In other cases, maybe only alphanumerical information is required. The idea is that by using this framework, you can predefine information requirements, group them, document them, specify them, but you can also apply it in a more ad hoc approach in a specific project for the specific information exchange, maybe to discuss how information from a structural engineer should be shared with the architect. And all the parts can be made optional. It might not even be necessary that documentation is included as part of a certain information requirements. If we look at geometrical information, we talk about 5 independent aspects: detail, dimensionality, location, appearance, and parametric behavior. We go through them as part of the part 1 standard, but also further explain how they can be developed in part 2. So the first thing is that we got rid of the fixed levels. We see it's more a continuum of detail, depending on the context, depending on the purpose, depending on the project scope, in a building project, an infrastructure project. So we don't assume that there are just 4 or 5 or 3 different levels. We'll go further in detail on describing how that can be specified. We also don't embed a purpose or a milestone as part of the detail definition. So we don't say there is a fabrication level of detail or a construction level of detail, because that is already supposing that the purpose is defined. However, if you say if the purpose is fabrication, then you should be able to specify an appropriate detail. Depending on the purpose, for different purposes, different detail might be required. The example on the left was also part of the standards. It's the detail for different, it's a multi-tubular tube, and in one case only the outside box or the outside enclosement is required. In other cases, the individual tubes are part of requirements. So that would already present, depending on the purpose, different detail. And the example on the right is in a heritage context. So the column to the left is required. Well, the column on the right requires much more detail. All the individual mortars, and possibly even the cracks or the breaks within the column in the context of heritage, in context of preservation of historical buildings or monuments. The dimensionality, that is a way that you describe to which extent is a geometry can be used to derive certain meaning. If we 3D is of course well understood, that this would be valid to have objects which have a width, a height, a depth, or length. All the extents can be used and define the objects in a 3-dimensional environment. In 2D, that would say only length and width, only for the surface or blocks, only 2 extents or 2 dimensions are relevant, which means in many projects you might initially only require just the delivery of a 2D layout with only the extents of maybe the cabinets, maybe the parking spaces, where the 3/3 dimension might not even be a requirement. 1-dimensional would typically be referring to a linear object where only the axis line itself is relevant, but other information might be attached to that object using other ways, maybe alphanumeric information. For instance, to do calculation of a ventilation system, all the dimensions, the width and heights may be part of alphanumerical information, whereas the length itself might be a part of the geometrical information. And in the case of 0D, which is still a bit controversial subject, only the fact that the object is there, is located somewhere, but the extents themselves are not embedded as part of the geometry. That would typically be a symbolic object, which is just representative of something but not defining the extents. Geometrical information, the location aspect, there we mainly make the distinction between having an absolute position and orientation against the reference coordinate system. Typically that would be national grid to define a geolocation, global position. Whereas relative positioning, that's typically what we see in IFC as local placement, is a relative position against another object. A window is not positioned absolutely against the world or grid, but is positioned relatively against a wall in which it is embedded. The wall itself may be positioned against a building story, and a building story may be positioned relatively against a building. In most cases, the majority of the objects in models typically are positioned relatively, but some of the objects may have a need to have an absolute positioning, an absolute location. Appearance, again, here we don't consider this to be just a set of possible appearance levels, but we rather say that the appearance itself is effectively disconnected from the geometry. And the main reason being that the appearance itself might be used to provide or to present information which may be at a different detail, you could say, than the geometry. You could have a very simple object, but by adding a refined, realistic appearance, using colors, using textures, you may already communicate information. So the appearance only concerns the visual characteristics. There could even be that there is no requirement at all for an appearance. For a clash detection, you don't need a color, or you don't need a texture, or you don't need a transparency. You simply need the geometry. And for that, there is not specific requirements on appearance. In many cases, you could also use other ways to describe appearance, and we see a few examples later on in the presentation. Finally, for detail, we also talk about parametric behavior. And here, yes, you always have to consider that level of information needs is used to describe your information in a particular context. And it means that, do you have a requirement that the geometry as being delivered is also parametric in its behavior? Which means that if you really want to have a delivery of geometry with full editability, as it was originally intended, you would require the parametric behavior to be included. But in other cases, for many purposes, only the outcome of the geometry is required. So maybe a boundary representation would be sufficient. This is an important aspect because the choice that you make also has an impact on the chosen file format, the chosen schema. Maybe this is one way where sometimes native models may have an advantage over IFC files. And in IFC files, that would really have an impact on the chosen model view definition to what you transfer. So for instance, parametric behavior would be really difficult to transfer using just a reference view, model view definition, but a design transfer view might be more suited to support, at least to a certain extent, the parametric behavior. Alphanumerical information, and we will return to that in the second part of the presentation, mainly is concerned with having all the identification information of the objects, name, classification, code, the numbering system, any kind of way to identify the objects, and then the information content itself, and then we're thinking about property sets and properties. I think that's well understood. And finally, documentation, that was also considered as an important part, because not all information is just embedded in the typical models, but can be also embedded in external documents, referenced, and data sheet. Not all the information of a data sheet would always be embedded as part of a model delivery. It could be contracts, could be other manuals or specification documents, or maybe an installation report. Some points of attention: the breakdown structure is hierarchical in nature, and we clearly want to be able to specify your information requirements at any position in the hierarchy. For instance, if you have an information requirement for all building elements, you would prefer not to have to repeat that at every every leaf in the tree. So maybe you can only define at once that every managed object should have an asset code or should have a certain product number. And if you go deeper into the breakdown structure, specific objects might have very specific requirements, which you don't want to repeat for every single object or object type. The last part of the standard also presented the first attempt to give a more pragmatic example, but there that was not completely developed, so part 2 would further develop on that. Now, the second part of the presentation would focus on more pragmatic approach, guidelines and application. And we assume that the intention is to develop that as a technical report, more as a proposed methodology to adopt and to apply and implement level of information needs. Now, the first one, that's quite extensive diagram, but this is the main methodology on how to specify level of information needs. So the idea is that you start from the prerequisites, purpose, milestone, actor, breakdown structure, and then you would specify the required documentation, required geometrical information, required alphanumerical information, and then deeper down we can further specify the different geometrical aspects, and everything combined would then become the compilation of level of information needs. Outside of the borders, we try to link that to existing standards. For instance, purposes might be derived from maybe from the use case database. Milestones can be aligned to international standards with a fixed set of project phases. Maybe there is a national document where the typical project phases have been defined, or the main project milestones. Same for the breakdown structure, might be derived from an existing classification system, or maybe it's based on an IFC schema, or there could be a custom structure specific to the client. So these are defined outside of the level of information needs standards. A second important link, and that is where we make the bridge to the previous presentation by Frédéric, is that we say all the property definitions that we require as part of the alphanumerical information may be already defined in a property server, maybe already defined in a data template, or from a data dictionary. So here we can link all those properties to a data dictionary or to a data template, which then gives you the advantage of having standardized property with all the attributes that are related to the property also there. However, it is possible that some properties are not defined yet, are not available yet, and then it could be just an ad hoc local definition of properties for the project, for the client, for one of the stakeholders in the project. The end result, the compilation, would then be used to generate an exchange file, a level of information needs specification file. That is the subject of the part 3 of the standard. And here is also a bridge to make, for instance, to the buildingSMART IDS standard, which is closely related to level of information need in the way that you specify required information, alphanumerical information. The second part of for part 2 are some pictures, so not much text. Here we try to develop some examples on how to use the different ways to describe geometrical information. For instance, there are one of the aspects that we want to describe is the outer shell of the object, or the envelope. And depending on your information requirements, maybe only a bounding primitive is sufficient. In the initial phase, maybe just the outer extents of a box or a cylinder 3D, or even just a circle or a rectangle in 2D might be sufficient to describe the geometry of the object. So in that case, full geometric information might not be required. Second aspect is that for detail is that the object itself might consist of a single shape, and maybe the shape as a result of a series of geometrical operations, but still a single shape, or it could be a combination of all individual components, each with their own geometrical information. That is typically something you would have to describe to better clarify how you want the geometrical information to be delivered. The same with shape connections. Initially, the object itself maybe just be an extruded profile, but depending on the purpose, depending on the requirements, depending on the objectives, the shape itself might be altered to to ensure that connections could be made. For instance, there is an extension, a console on a column to support the beams, or maybe the outline of the object itself is adapted to fit within the project. Or there could even, and that is where we go across to the breakdown structure, that additional objects are required to describe the connection, in this case between different steel profiles. Depending on the purpose, it might mean that at some point the beam might just be a single object. At a later stage, that object might be extended with several additional objects, each possibly with their own information requirements, with their own detail, with their own alphanumerical information, or even documents attached. Something that is also, in many cases, useful to have as part of a geometrical definition would be the operating or the clearance zone. For instance, the area in which doors will open might be required to check for possible collisions or to check for fire safety, safe passage. Or in this case, that is something that we also found inspirational in the ISO 16757 part 2, where different types of operating zones or clearance zones, or maybe just the zone embedded for package, can also be combined. To give you an example, during operation, at the left side of the boiler, there should be some room to access the control panel, or maybe at the top side, there should be some clearance. So that can also be embedded as part of the geometrical information. And then if that is properly defined, that could be used for clash detection purposes, for soft clashes, to check that there is sufficient area around or in front or above the object. Openings, initially maybe openings are not defined, but at some point the main functional openings, like the door openings, window openings, maybe floor opening, is required as part of the geometry, or even the individual the openings for the passage of ducts or pipes should be a part of the geometrical information. Otherwise, clashes would be generated and they have to be resolved. And maybe depending on the purpose of the object or the type of object, maybe if there is a passage that should be constructed on site, that can be treated differently than something that is part of a prefabricated wall or floor slab. Apart from the outer shell of the geometry, we also can specify what is required for the inside geometry. Maybe there is a cavity, maybe there is an opening, maybe it's a hollow object. Should that be part of the geometry or not? Especially in the early design stages, maybe only the outer shell is sufficient. In other cases, especially for if the openings are used to derive maybe the volume or weight of an object, or if you have to check if other objects can pass through, then the internal openings or the internal cavities should also be part of the geometry. And then we can talk about features like roundings or smaller details or extrusions, or maybe it's even the chamfered edges of a column. All of these aspects of geometry define the geometric detail. And what we want to achieve is that this is a set of a language or a way to specify those requirements using a more varied language than just level 100, 200, 300, 400. We already mentioned appearance, and appearance can be seen in general just as something that represents materials, or it can be used to represent some more semantic or thematic information. So again, this is not just a level, but it is a way to describe how the appearance, the visual characteristics of the geometry which are attached to the geometry are used. Maybe the colors might represent a function. So maybe we want to represent all hot water pipes in red and cold water pipes in blue. And that would be a typical example. Although, depending on the information, it might not even be necessary to have that as part of the appearance, because maybe the analysis software might generate the appearance based on other properties. In many cases, the appearance is related to the materials. Sometimes you just need no appearance information at all. Maybe you need it for individual components, individual parts of the object, or maybe the appearance itself is just an attribute that is attached to the geometry, which refers to a catalog of product colors or standardized color systems. And here there are some examples where appearance and detail may vary independently. The object on the left is very, there's an object with low detail, there's not much detail included, but the appearance itself gives it a very complex, more realistic appearance. Or with the same detail, you could have a different appearance applied to the object. And at the other side, even with different detail, the same appearance could apply. So a textured, more photorealistic appearance might be applicable, and in some cases, even for just a singular object or with objects with all the individual components. So that is one of the reasons why we made a distinction of appearance independent of detail. And finally, location. If we not go deeper into that would typically be a way to position objects against a global reference system, against a national grid, using GPS coordinates or other aspects. And for dimensionality, here is another example where, for instance, for an analytical calculation, only the 1D dimensionality would be sufficient. You need the access lines and the connectivity, and all the other information, for instance, in a structural and a calculation software, would be attached as alphanumeric information to the geometry. Also beware that we are not going beyond 3D, so we are not saying a dimensionality 4, 5, 6, or any other number, so we stick to 0 to 3. Finally, the parametric behavior type of geometry would typically be either the end result, like a boundary representation. Technically, it's still editable in modeling software, but it does not contain the modeling history or the full parametric behavior of the original geometry. And it might be that is sufficient for operational use or sufficient for class calculations or quantity takeoffs. But in other cases, a more parametric description might be required, like having constructive solid geometry representation, where the different geometric operations are also contained within the geometry. So you can still make changes to an extrusion, to a position of a primitive, to a radius of a cylinder object, or to the different Boolean operations which are part of the operation. So this is containing the modeling history, and other representations may not. However, when you specify that you require fully parametric behavior, it may have an impact on the possibilities or the limitations on exchanging information between software systems. Typically, parametric behavior is only fully supported if you use the same system as the original author. Maybe that might even be tied to specific software systems, using scriptings or using plugins or more visual programming environment. To a certain extent, the design transfer model view definition, to my understanding, has a fair support of supporting some aspects of parametric behavior, but it may not be possible to transfer the full parametric behavior between two completely different software systems. And finally, all of these aspects are related. So some information might be available in the geometrical information, like the width or height of a door, but it could also be attached in a different representation. It might also be part of the alphanumeric information as a property and a value, or it could refer to an external document, as part of the set of documents, maybe fire safety information and regulations, or declaration of performance, or data sheet. And some of those bits and pieces of information in such a document might be embedded as part of the alphanumeric information. Are we getting rid of levels? Well, the idea is to not define levels as part of the standard, but give a methodology which you can use to define levels or labels. So a label, and it could be called A, B, or 1 or 2, or any way that you want to label it, would actually be the summary or a synthesis of all these different aspects. For instance, if you want to have a label for your geometrical information, then you should ensure that as part of your definition or your description of the label, that you include different aspects: detail, dimensionality, location, appearance, parametric behavior. And you could even say that a label is a more convenient way to summarize those requirements. And that is something we also have been discussing with members from the BIM forum team that is working on the level and the LOD specifications. So we'll see if this approach might be adopted or not. And in a more human readable form, how would you specify or state your level of information need? That could be just using a certain form or a template where you say, I would define the different prerequisites. Maybe the purpose is visualization. The object would be the project site. And then you can say, for detail, I simply need a simplified boundary representation. Maybe it could even just be just two-dimensional. The appearance is just symbolic. Maybe a simple color is enough. There is no requirement for parametric behavior. And for the information content, the address, the geolocation, and other properties could be the requirement. The third part is where we would define an exchange format to be able to describe the level of information need in a machine interpretable format. That is in preparation. It's not published yet, and that is where there's a lot of collaborative work is going on, especially within CENTC 442 with between the different working groups, but also with external organizations. The idea is that it would be based on a UML schema, and then that typically an XML-based exchange format could be derived from the UML schema to allow more automated verification if information delivery is actually fulfilling the level of information need requirements. But you can understand, and that's why we have the different presentation, that there is a relation between the way that properties are managed or defined, the way that, for instance, if exchange requirements in IDM are defined, the way that IFC is already providing a breakdown structure or a schema, but also what the relation with model view definitions or with the IDS standards. That is, for instance, the current UML which is being developed. It's just a simple fragment of that. You have seen this picture before in the previous presentation, so that has been a straight reference to allow us to use the same structure, so not reinvent the wheel, but rather using what has been defined already or what is now being defined at ISO 23387, with sets of properties, data templates, and the reference to documents. So that same structure, the yellow parts of the UML schema, would be directly derived from that standard, to not invent something that is similar but not the same. For geometrical information and for documentation, that still needs further refinements as part of the exchange format. Some final thoughts before we return to the audience. There is currently work being done to move the level of information needs standards to ISO. So it has been published as EN 7412 Part 1. Unfortunately, number 17412 is not available at ISO, so we had to adopt a different number, 7817. Currently, the drafts of the text have been already approved, but based on the large series of technical comments, it was decided to have a revision of 17412 in the context of updating or extending that to the ISO level. The original authors are involved, but more experts are being contacted. It is now being developed within CEN, but under Vienna agreement, so it would be the same at CEN and ISO, obviously to move beyond the borders of Europe, but also to be able to better fit within the ISO standards like 19650. So that is going on, and we have a hope to be able to have a finished updated version of Part 1 ready beginning of next year, and hopefully to be published next year. So looking at the timeline, so the original drafts at the European level from 2016 have been published in 2020, but now the work is moved to the ISO level 2022, and parts 2 and part 3, which are still in draft at the moment at the European level, will probably also follow the same route. So the idea is to have a coherent set of standards, the 7817 part 1, and eventually also part 2 and 3, to also adopt the practical implementation and the data exchange format. And of course, that is why we have the two presentations together. So even the 17412, there are relations to IFC, relations to data templates, relations to dictionaries, relations to the management of property. So everything is interlinked, and that is why we see that there is a good collaboration both at ISO and at SEN level. Also to understand that, for instance, the scope effectively to discuss geometrical information, to discuss documentation and alphanumeric information, it's not exactly the same scope as what we've seen in the previous presentation, where geometrical information at the moment is not considered. So it's mainly the management of properties and definitions. And for instance, the information delivery specification from buildingSMART is also focusing currently at alphanumeric information. So that's, which I think it's fine. It's correctly defined, and it's also a pragmatic focus. But we have to understand that it's not exactly the same as level of information needs. So the focus is on properties. No geometrical information is described, no documentation, and maybe that's also an important thing to understand. This assumes that everything is by definition mapped to the IFC schema. One of the concepts of level of information need is that you are able to align that. If you use IFC as your breakdown structure, you can perfectly adopt IFC schema as part of that, but it could also be a custom schema which may not be IFC based. Especially what we've seen when owners are defining their requirements, they're not thinking in terms of the IFC schema, they're thinking in terms of the objects or the assets they want to manage. So that would be the main focus. So with that, I want to thank you for the work. Please consider that especially part 2 and 3 are work in progress, but with good collaboration between SEN, ISO, and buildingSMART, we think we can have a valuable result. Thank you.
So I think then Davis has a few questions that is then really concerning the content. Do you see them? So in the middle of the screen?
Yes. So one of the questions is the relation between the exchange information requirements. I think the result of stating your information requirements, those would typically be initially defined by the owner, based on asset information requirement, based on organizational information requirements. Those would be then translated to exchange information requirements. And what we think is that the level of information needs is one of the methodologies to actually describe the content within the different information containers to be delivered. This would help you to state in more specific way what is required, for instance, for the owner, for the assets they want to be delivered. Maybe there is a requirement on all the spaces need certain properties, or there is a requirement that there is a certain asset code to be attached to all the managed objects. So we think that it is a complementary standard when as part, and if you look at the SEN guidance on how to develop or how to describe an exchange information requirements, the statement of the level of information is actually a subpart of the exchange information requirements. The second question from Davis relates to the link with the data dictionary. The geometrical property names, value boundaries could reside in dictionary. I think if you look just at everything as being definitions, descriptions, I think that is possible. The same way that you could say, I can describe all the geometry, but we have noticed that based on the experience from the industry, the wide adoption of LOD specifications, that's handling geometrical information in a slightly different way than alphanumerical information is still very common. You could say eventually every geometric information is just information. It's just a series of you could simplify it as concepts with values, with descriptions. But many of the usage of models for analysis, for clash detection, for quantity takeoffs are effectively using geometrical information. So we want to handle them differently. But I think there is no real constraint in being able to capture those requirements. Maybe if these are a series of statements, like we want a detail to have an outer shell, to have all the openings included, maybe to also have the internal cavities, then you could say this could be effectively developed as clauses or as description, more descriptive text. Okay.
Okay, perhaps we have additional questions then in the chat, but perhaps there's also one of the other questions here in the room.
Maybe there's a question.
I noticed there was a large focus on the geometry. Is there also possible to focus on information which is not connected to geometry? So, as an example, could you specify at a certain stage that you decided on that a wall should have an RSI value without needing to define the width or any other attribute about the wall? And I'm just using insulation value as an example of information that's not connected to geometry.
I think they are interconnected. If you would say, typically, if you perform a quantity takeoff based on a model, you would typically use the pre-calculated quantities. And those pre-calculated quantities, like for instance in IFC, the base quantities are effectively derived from the model, but they are captured as alphanumerical information. And I don't think at most points as part of the quantity takeoff, you would rely on those quantities as alphanumerical information. Of course, they are stored separately, for instance, in an IFC file, but yes, they're still related. If you would update the geometry, you would expect the quantities to also be recalculated. That is not an automatic mechanism, for instance, in such a schema. So that's the reason why we typically would have quality checks to ensure that there is a coherence between that information. But you would typically not go measure the width of a door by clicking on two vertices in the model. You would typically look if the width of the door has been embedded also as an alphanumerical information. So I think in most extracts that you would generate from model, you would use, for in this case, the alphanumerical information, even though it is directly related to geometry. So what we want to achieve is that...
I'm not sure. I'm trying to come up with another analogy. What if you had a level of information need that you wanted to specify for the whole building where all of the fire separations are? So that's not really connected to geometry. It's just a requirement that they need to be specified, even if you don't identify all the objects that are connected.
Yes. Not every object has geometric information attached, and that's why the breakdown structure itself, the choice of a breakdown structure is not fixed. We don't say the level of information each should use, for instance, uniclass, or should use the IFC schema, or should use omniclass. But we say you use the breakdown structure which is most relevant, and if those requirements are defined at the building level, even if the building object itself does not contain geometrical information, it may have many alphanumerical information parts, or maybe have documentation attached. So the idea is that, well, the level of information needs standard assumes a certain flexibility, and that is why we also see, for instance, for the alphanumerical parts, that we didn't want to reinvent it. We want to strongly align with the work that has just been presented in the previous presentation. But also to understand that there is a certain hierarchy to where you define your requirements. If you define a requirement for doors, it might be applicable to all doors, but maybe some of those requirements might be very specific to fire doors or to exit doors. So you would attach those requirements at a different position in the breakdown structure. And maybe at the top level, you might say every object should have an asset code. So you don't have to repeat that requirement for every possible object. Otherwise, it would be very difficult to develop that. But indeed, you don't have to be restricted to always have geometrical information with the object.
So now I think you are together, yeah. It's the question and the answer. So the time is running. We have 2 or 3 open questions in the chat. Don't know if we shall invest the time, or probably we have to close. Yes. Yeah. So my boss says we have to close because of timing. So anyway, so hopefully we will have the opportunity that you will perhaps answer the questions offline. Many thanks to you, Stefan, that you took the time and engaged here remotely. It worked far better from technology than yesterday. So thank you also to the team. Thank you to Frédéric for this engagement and this presentation at the beginning. And thank you for you all being here in Montreal, in the room, in presence, and all our participants outside in the air that also participated. So thank you very much. Then we close for break, and we'll one or the other see us soon again. Thank you.
Thank you. That's a great question.